Today for day 6, we are representing sinusoidal functions. For this, we're just looking at putting together everything that we've done so far. It's quite a short lesson, so we're just going to identify the equation of a sinusoidal curve, given some key information, okay? So copy out this chart, and what we're going to do is use y equals sine x, which is our base function, and we're going to apply an amplitude, a period, and a phase shift, and come up with a new equation from that. Okay, so to start, we're going to have an amplitude of 2, a period of 360 degrees, and a phase shift negative 45, which also means left 45 degrees. Okay, so when you're doing that, remember that your amplitude is your A. That A comes in front of your equation, or sorry, in front of your sine. So when it goes in front of your sine, it's just the number that you see. So you see a 2 for your amplitude, so put a 2 there, and then you can write sine. Our period, which would affect our k value, is 360 degrees, and since that's our base function period, we don't have to change it, so we don't have a k value. But we are going to have a phase shift in our graph, which is left 45, but because we write it opposite in our equation, it's going to be a plus 45 degrees. And then I haven't given you any equation of your axes to move your graph up or down for a c value, so you can just leave that blank as well. Okay, so there's your new equation given that information. So we're going to continue on to our next one. Since it tells you your amplitude is 1, you don't have to write a 1 out front, so you can just start with this writing sine. Okay, your period is 180 degrees. So remember, to get that 180 degrees, you would figure out what you have to divide 360 degrees by, which is 2. So that is going to be your k value there. So you're going to write a 2 in front of your brackets. And then since you have a phase shift right 60 degrees, you will have brackets, and you're going to have to write opposite, so you're going to have a negative 60 degrees there. Again, we don't have a c, so you leave the end of your equation blank. Okay, moving on to your next one. Sine x, we have an amplitude of 0.5, so you just write a 0.5 out front of the sine. Then we're figuring out what we are going to divide our 360 degrees by to get 720 degrees. And remember that that is going to actually be divided by a fraction of a half, because when you do 360 degrees divided by 1/2, you flip and multiply. So it'd be actually by 2, which is 720. Multiply by 2, sorry, which is 720. Okay, so you're going to put a half, or 0.5, it doesn't matter how you write it, a half in front of the x, and then since we aren't moving left or right, we don't need brackets, we can just leave it as an x, okay, and your equation is done. For the next one, don't let it scare you that it's the root of 10. That is fine, just keep it like that. Write your sine. 180 degrees would be the same as example number 2. Figure out what you divide 360 by to get 180 degrees, so your k is going to be 2. And then again, no phase shift, so you're just going to write that x there. We don't need brackets. Okay, we're not moving it left or right. And then our last example, amplitude of 1.4. We have sine. We do not have a phase, or sorry, a period change because it's 360 degrees, so nothing in front of our x, but we do have a phase shift of left 120 degrees. So you're going to have to put it in your brackets, but remember it's opposite when we put it into our equation. So you're going to have x plus 120 degrees. Okay, that is your one chart, and you should be able to come up with that today, given some information. Lots of examples of that in your homework. Okay, and your last example for this lesson, we've actually done before, but you will see a couple examples in your homework tonight of given a graph, I want you to explain what transformations were applied to the green curve to come up with the black curve, as well as come up with the equation. Okay, so remember that you have your 5 main points on your sine graph. So 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. Okay, and if you remember from the one lesson, I told you it's easiest to tell what your maximum and your minimum points are in a graph, right? Because you can see where the curve changes direction. So let's look at just our maximum here, and you can go and you can find your maximum in your graph here. Okay, so here's your max, and here's your max. So let's see what happens to our max, what we've done to our max. So we have moved it over from 90 degrees over to 270 degrees. So let's figure out what the difference between that. It's 180. And then we've also taken that point and moved it down. 1, 2, 3, 4. So we've moved it right 180 degrees and down 4. Let's see if that happened with our minimum as well. So here's our minimum, and here's our minimum on our transformed graph. So let's see, we're going from 270 over to 450. So 450 minus 270 is 180. And then you are taking that point over at 450 and moving it down 1, 2, 3, 4. And then we're going down 4. So because our graph is periodic and sinusoidal, we know that what happens with our max moving it should happen with our minimum moving it, which it does. So you can tell me that our transformations are horizontal translation plus 180 degrees, or you can write right 180 degrees, and then vertical translation negative 4, which would be down 4. Okay, you either need to write plus 180 or right 180, negative 4, or down 4. Okay, one or the other. And then just plugging that in your equation, remember that this is your phase shift. And you can see here, this is your equation of your axes, that negative 4. So your equation of your axes, or the middle of that sine graph, is right through the middle of your max and your min. Okay, your amplitude is still 1, so that's why we don't have an A value out front, and your period is still 360 degrees, 135 to 495. Okay, so you'll have a couple examples in your homework that you'll have to do that as well tonight. So here's your homework. Try it out. Let me know if you have any questions. Good luck.